Hi everybody. We're solving statics problems. Our topic, three-dimensional force systems. Our question, find the angle between the 200 newtons force shown in the figure and the line OC. Yes, we're given such an inclined plane. On the inclined surface of this inclined plane, there's a force, a 200 newtons force F. The line of action passes through point A and point B. The coordinates and dimensions are given. Point O is the origin. We're asked to find the angle between this force and line OC. Let's find it. When we examine the figure, we see that the line of action of the force passes through A and B. In other words, vector AB and the force vector are in the same direction. Therefore, the angle between vector AB and vector OC is the angle we're looking for. If we find the angle between vector AB and vector OC, we've solved the problem. So let's find it. We know that we can find the angle between two vectors using dot product. So let's find it. First, let's write AB and OC in terms of unit vectors. Let's write the vector AB. We go from A to B. We write it by looking at how far and in what direction we go, parallel to the axis. First, 240 millimeters parallel to Y in the positive direction. Then, 120 millimeters in the negative direction, parallel to X. And finally, 80 millimeters parallel to Z in the positive direction. I got from A to B. In other words, vector AB is found to be minus 120I plus 240J plus 80K millimeters. We also need the magnitude of vector AB, so let's find it from the Pythagorean formula. We take the square root of the sum of their squares and find the magnitude of vector AB. It is 280 millimeters. Let's move on to OC. This vector is a vector in the xy plane. Therefore, it has no z component. The x component is plus 120i. The y component is plus 240j. Thus, we have written the vector OC. OC is equal to 120i plus 240j millimeters. We find its magnitude again using the Pythagorean formula. 120 square root 5 millimeters. Yes, after finding these values, we can now perform dot product. We learned how to find the dot product in terms of rectangular components. We learned that when finding the dot product of any two vectors in terms of rectangular components, we can use the formula P times Q equals PXQX plus PYQY plus PZQZ. Therefore, we multiply the coefficients of the i's, multiply the coefficients of the j's, multiply the coefficients of the k's, and add them. Let's do the same thing here. Minus 120 times 120 plus 240 times 240 plus 80 times 0. Because the z component of OC is 0, we write the magnitudes below. And now we can calculate theta from here. We find it. If we've found cosine theta, then we've also found theta. We find theta equals 54.9 degrees. Let's solve this problem a second way, through geometry. Remember this. Whatever angle a line makes with another line, it also makes the same angle with all lines parallel to it. In other words, whatever angle AB makes with line OC, it also makes the same angle with all lines parallel to OC. So, let's consider line AD, which is parallel to OC. Whatever angle AB makes with OC, it also makes the same angle with AD. Let's construct triangle ABD and find the angle between AB and AD in this triangle. Let's find the lengths of the sides of this triangle. We can do this using the given geometry. By the way, of course, I'm dividing the given dimensions by 40 to minimize the numbers and avoid dealing with large numbers. It doesn't change anything. It doesn't affect the result. The important thing is the ratio of the sides to each other. These could also be called 2K, 3K, 4K, 6K, 7K. But there's no need for K. Side AB is 7 if we divide 280 by 40. We find side AD using the Pythagorean theorem. One of the sides of the right triangle is 6 and the other is 3. Therefore, the hypotenuse is square root 45. The other side is side DB. That is also the hypotenuse. The base of that right triangle is proportional to 6, and its height is proportional to 2. This also makes square root 40. After finding these values, we can easily find angle theta using the law of cosines. What did we say? The angle between line AB and line AD is equal to theta, because AD and OC are parallel to each other. Yes, we will find this angle. Let's find it using the law of cosines. In triangle ABD, let's write the law of cosines. The side opposite angle theta is side DB. So, we write it down first. dB squared equals AB squared plus AD squared minus 2AB AD cosine theta. We substitute the values in the figure into this formula. From here, we find theta. We obtain the same value. Theta equals 54.9 degrees again. Goodbye.